Hello there, random smart person on the internet. This piece of ice came from my ice maker in my kitchen and is no way the oldest piece of ice in the world. However, a University of North Dakota's geologist unearthed the world's oldest ice sample in Antarctica. Professor Jaakko Pukkanen, professor of geology at UND, and a team of researchers in 2018 drilled 10-meter core samples of the ice found under the dirt in the Ong Valley of the Trans-Antarctic Mountains. According to Dr. Pukkanen, ice is one of the best sources of information to tell us about the paleoclimate on Earth. In order to evaluate the ice samples for its potential as a paleoclimatic archive, geologists first needed to figure out how old this ice mass is and understand its history. The 10-meter-long cylindrical ice cores may open the doors for researchers worldwide by giving them a deeper understanding of the Earth's ancient climate. To reveal these secrets, researchers are examining the amount of carbon dioxide contained in bubbles in the ice. The dwindling amount of ice is housed at UND and is shared with collaborators to analyze carbon dioxide, DNA, biological activity, and other indicators of past climates and environment. Atmospheric scientists are taking the task of carbon dioxide analysis, while geomorphologists study the process of land formations on Earth's surface. In Antarctica, they are interested in the evolution of the landscape, how much it changes or doesn't change. Researchers chose the Ong Valley after poring over hundreds of aerial and satellite images of the 1,000-mile-long mountain range. Geological peculiarities in these photos piqued scientists' interest, and by relying on their experience, they expected those oddities to indicate the presence of buried ice where one would not normally find it. They visited the area, and after digging, lo and behold, they started finding ice. The research team uncovered two separate glacial advances buried under the dirt, one on top of the other. Scientists are still studying how the glaciers impact the formation of the landscapes as the top layer slowly sublimates. Once the expedition team returned to UND, they began the process of dating the ice. They accomplished this by melting portions of it to get to the dirt and sand particles inside. Quartz crystals were extracted from the rocks and were washed to remove any impurities. Why quartz in particular? At or near the Earth's surface, over a period of millions of years, the atoms in the minerals interacted with cosmic rays in ways that caused nuclear reaction within the minerals, resulting in the formation of new isotopes, such as beryllium-10 and aluminum-26. The cosmogenic isotopes have a decay rate that can be used to calculate the age of the sample. They sent about 30 samples to an accelerator facility run by the National Science Foundation at Purdue University. By bombarding these samples, researchers were able to yield concentrations they can use to calculate the age range for the samples and thus the ice itself. The experiment indicated that the ice dates back 5 million years, and the research has been published in the journal Nature. The paper details the potential for the ice to reveal secrets of the Earth's ancient climate. Of the two layers discovered, the one on the bottom was dated to be 4 to 5 million years old, while the upper layer was about 3 million years old. Drilling ice core samples in Antarctica means getting there while trying to keep the cores from melting on the way back. The trip to the Ong Valley isn't exactly an easy trip. First, the expedition team flew from North Dakota to Los Angeles, and then from there to New Zealand. Antarctica-bound scientists then had to journey the rest of the way via military supply planes operated by the American National Guard. I salute you. From New Zealand, the team traveled to McMurdo Station in Antarctica, and these flights don't end at McMurdo either. Once there, the researchers had to prepare their food and fuel and then transfer it from one guard aircraft to another to fly further into the interior. There, they broke down their pallets and supplies, repacked them into smaller stacks to transport by helicopter to the Ong Valley. Spending 5 weeks in the valley calls up for a lot of supplies, all of which must be handled by following the leave no trace rules similar to those imposed by wilderness hiking areas. That means hauling out every single paper cup or plastic bag. Even spilling something on the ground could lead to an environmental review. And if that liquid is fuel, the ground that soaked it up would also need to be hauled out in bags. The clock on the 5-week mission started ticking once they arrived to the buried glacier. They camped in tents with no heat, and since it was summer in the southern hemisphere, no darkness. Temperatures were about 12 degrees Fahrenheit. Think about pitching a tent in your own backyard and living there for 5 weeks in January and February. It's not exactly comfortable, and it's going to need some physical changes. It takes about 5 days to get used to the climate, and the cold-induced circulation changes makes your hands and face puff up. Returning to heated buildings would lead to a reversal of these conditions in about the same time. The cores that were excavated there went to California, where the National Science Foundation hired a freezer truck to transport them back to the researchers who had drilled them at UND. This freezer truck remained at 26 degrees below 0 Celsius, or 15 degrees below 0 Fahrenheit if we're using freedom units. This ice core's discovery will likely inspire other researchers to travel to the Ong Valley in search of ancient ice. UND scientists said they identified 22 likely places to find similar buried ice bodies in Antarctica. No one knows if ice actually lies under the dirt until someone puts a shovel to it. So there you have it. You learned about the University of North Dakota's science team that unearthed the oldest ice core samples to date. Leave a comment down below if you think you can handle the extreme temperatures of Antarctica to make these groundbreaking discoveries. Comments are good for the YouTube algorithm. If you're curious about radiometric dating, check out my first video here where I show the math behind how dinosaur fossils are dated. And always remember, have fun with STEM.